So hi, I'm Claudia Bianchini and I'm with Ludovic Saint-Bauzel. And we are here today to present a preliminary result of an interdisciplinary project on the automatic transcription of multimodal data. Does it work? Ça avance pas. Aspetta qua. No, ecco. Okay. Okay. Nowadays, corpora have become a vital tool for most linguists, and this corpora can be written, oral, or multimodal, depending on the nature of the data they contain. Multimodal corpora characterized by video are crucial for the analyzing of the linguistic role of the body, for example, when producing co-speak gesture or speaking a sign language. It is nearly impossible to know exactly how many linguistic corpora already exist. However, it is well known that compared to written and oral corpora, multimodal corpora are always scarcer and smaller. And what is the reason for this difference? One might think that linguists are less interested in multimodal communication than in speech or writing, but in my opinion, the issue is more technical. I think that we can all agree that collecting data that we can't process and analyze is pretty useless. And today, analyze the bodily behaviors is really challenging. So multimodal corpora are always harder to process than written and oral corpora. So let's take a closer look at where the problem lies. Before analyzing an oral corpora, we need to segment, align, and annotate the data. However, before doing all these stuffs, we have to transcribe the raw data, and we graphically represent them so they become readable, searchable, and therefore analyzable. The way raw data are transcribed depends on their nature. The oral component is transcribed using phonographic or orthographic convention, and prosodic information are represented through curves or specific graphical convention. But in multimodal corpora, transcribing the voice is not enough. We also need to find a way to represent all the body movements that are linguistically relevant, and this remains a major challenge. Raw data, once graphically represented, form the basis for the annotation of the meaning and the function of sign and gesture. To avoid circularity, it is then fundamental that the graphical representation of raw data remain independent from any preliminary consideration about the function or the meaning of the gesture or the sign. So let's take a gesture, this one, okay? Describing the gesture by a function, so it's a pragmatic gesture of epistemic negation, or describing it by its meaning, I don't know. If not, it can't be considered a transcription. It's an annotation. While verbal description of sign, like a shrug with palm up and the with palm up at shoulder height, I'm lost. Let's see. So while verbal description of sign and gesture can be considered as an independent transcription, like here, this description often lack consistency. It's hard to say, and are difficult to query, hindering computational analysis. To transcribe body in independent, precise, queryable, and readable way, we need to develop a typographic transcription system for the body. There have been many attempts to create an international phonetic alphabet for the body. Here are some examples developed for sign languages. They differ in terms of readability, focus on one or more body parts, compatibility with the data processing software that you used to use, and therefore their adaptation to computational analysis. Not hope. Okay. Once you have a transcription system, you have to closely observe your data to represent them in a detailed and consistent manner. For oral data, the operation is already time-consuming. But for multimodal data, it can easily become a nightmare because of the complexity of the existing transcription system and because of the multilinearity and complexity of the body. In fact, transcribing the entire body means taking into account the hand, the head, the bust, the facial expression. Each body part needs its own transcription. This is why the transcription of multimodal corpora are often limited to the hands. For spoken languages, numerous tools can facilitate linguistic works. For example, for well-described language, you can have speech-to-text software that can help researchers into the transcription process. However, for gestural communication, there is no body-to-text technology. Creating such a tool would speed up the transcription and make it more consistent. And I believe it will help overcome the technical barriers that currently limit the expansion of multimodal corpora. Our goal today is to demonstrate that creating a body-to-text system is indeed possible. To achieve this, we must turn to motion capture technology, enabling the automatic analysis of body position and movement. There are many different technologies of motion capture, each varying in cost, portability, invasiveness, and specialization to one or more body parts. However, few of these technologies meet two requirements for our transcription. They must be able to capture the entire body, and they must be applicable to pre-existing corpora, meaning applicable to corpora that were not specifically recorded for this technology. Without this second condition, we will be forced to abandon the analysis of every corpora, of every yet existing corpora, leading to a significant loss of time, money, and more importantly, valuable linguistic data. Therefore, only post-estimation meets our requirement. And then let's speak Ludovic.
So this kind of video starts to arrive now in literature as a good way to use computational model for body tracking and body analysis based only on a 2D camera video. And it has also this property to be multi-body video. And based on that, what we develop is a software that try to deal with two problems. One issue is using these tools, and the second one is being acceptable and usable for linguistic people. So the main idea was we take videos, we use this kind of model that are inside the server. So for I don't know if this is the same in all the countries, but we have some anonymization issues. So we needed to use software that are inside the lab and inside our server. So we installed the server with different kind of models. And then we did what is useful for the linguistics. So this is a model that we can find online. And then the work we done is based on this model, we are able to make a software that is able to create the plotting and the information that will be useful for the analysis. So at the end, it gives us this kind of software based on the computer. We provide the video, which is sent to a server, which is inside our system. We use different, so we can use, because this is a very intensive research model, so we can use multiple kind of models, so we can choose the best one for our corpus. And as an answer, we give back this, so we do this interfacing to be able now to use this as features for the sign language analysis and corpus. And in our case, it will be multiple degree of freedom that will be used based on the different actuator or different members that are useful for the analysis. So now I let the floor to the question.
Okay, so at the end, as a linguist, I obtain curves. But analyzing data from curves require a constant reinterpretation of the curves, making it difficult to find regularity or to query it to specific phenomena. Because curves are just a visualization tool and not a transcription system. We think that the greater the similarity, I don't like the words with Y at the end. The greater the similarity between the way the transcription system describes the body and the way the pose estimator analyzes it, the fewer difficulties we will have while automating the transcription process. Therefore, what we need is a transcription system based on the same biomechanical approach as pose estimator. And this is where Tipanot come into play. Okay. Today, my aim is not to present Tipanot. Yesterday, my colleague Claire Danet and I presented the poster that is still here, and I have it included as it is in my slide. I will not revisit the specific, but I invite you to come to speak with us if you want to know more. And for our purpose today, you need to know two things about Tipanot. The first is that in Tipanot, the body, the movement of the body segment are described following a biomechanical approach. This allows for an extremely precise description of the body movement with a very limited inventory of typographic characters. The second thing to know about Tipanot is that its description of movement is divided into two phases. An initial posture, which is just a starting point for the transcription. This posture is chosen by the researcher based on the segmentation of the sign of the gesture, and then the movement itself, seen as a sequence of variation of degree of freedom, so flexion, extension, etc., of the different body parts. And the description of this variation begins just after the initial posture. Okay. Tipanot will provide a detailed description of initial posture and movement across all the body parts. However, the more you want to be complete and precise, the more transcription is time-consuming, and Tipanot makes no exception, unless you use a pose estimator to pre-process all the data. From the pose estimation data, so the curves that Ludovic gave me, it is possible to obtain the Tipanot transcription of initial posture using a very simple Python script. Each range of values derived from the pose estimator is associated with a sequence of Tipanot characters. The researcher only needs to define where they want to set the initial posture. This choice will depend on his research objective, but does not affect how the script will function. So while I speak, my slide showed you the transcription of various potential initial posture displayed from a video when the head moved to the full left. I never know what is the left. So this, and this. For the same data, it is possible to transcribe movement. This is also done through relatively simple Python script that define the pole of variation in degree of freedom. In our case, if the head is moving to the left or to the right, the amplitude of the movement and the speed of the sign. The value obtained are then associated to string of Tipanot characters. And so the researcher only needs to specify the duration they wish to analyze, starting from the initial posture they have already transcribed. Again, this choice depends on the researcher objective, but does not influence how the script operates. While I speak, you can see the transcription of head movement from the same video, choosing different initial posture and analyzing various lengths of video. We have focused our example solely on head movement, as these movements were primary in the lexicon project that were the project where we worked together. The tool we have developed in this project serve as a proof of concept that what we aim to implement. In the near future, our intention is to extend the post-estimation model to every body part and then link them to the string of Tipanot characters. Yes, it's just no, il est juste planté. There is something wrong. Okay. This will enable to transcribe all body components of multimodal corpora in a fast and reliable way. This will contribute to bridge the gap between multimodal and oral data processing, and we hope this will lead to increase the number of corpora available, allowing a better comprehension of the role of the bodily communication, either in sign language or gesture. And thank you very much, and thank you to the Transcribe team that developed Tipanot, so Claire and I, but and if you want more information, we have a very good website and a book that is edited by Yanis.
Thank you, Claudia. Thank you, Ludovic. Any questions from here?
Yeah, I have a question. This Tipanot, this kind of, script that you're using, it looks like it would be very useful as long as we don't have video. Yeah, now, I mean, video is very cheap. And so before maybe it was necessary to say, okay, I want to learn sign language so I can read this Tipanot or whatever it is, and then understand what I have to do and so. But now it's, for example, for learning sign language is probably much easier to just watch video and so on. And also for analysis, once you get the data, from the video analysis, it might not be necessary to convert it to a script and then do an analysis on that. You can just do the analysis directly on the actual physical data. That's my impression. So
I have two answers. The first answer is that our system, the goal of our system is not to make people learn some language. It's just for linguistic analysis. And then my second answer is a question to you, but to everyone. Do you think that when we analyze an oral corpora, we just use the sound? We transcribe it before because we need to search information. And in a record of audio, if I want to find a word, I have to hear all the audio every time. So if I want to make an analysis of phonetic about how I pronounce house, and I have like 1,000 hours of audio, what I do is that I transcribe and then I tell to my computer, find me every time there is house, and he finds it to me, and then I hear it. But I have to find the information. And so Tipanot will allow to search into the corpora. And then I think that it's impossible to think that we will take the video and we will throw it and say, okay, we just use Tipanot. But we really need a transcription system to find the information about sign language, and to see something that maybe your eyes can't, if you just use your internal memory, it's very hard to find a regularity into language. And so, but with Tipanot, you can search from an information and then I say, oh, okay, I see that there's a irregularity that maybe I haven't seen before. With just my eyes.
Yeah, I mean, that could be very well true. I would think that if you, for example, if you do the audio analysis with some kind of clustering, maybe that doesn't exist yet, but it could be possible to do analysis directly on the audio too. I mean,
As I know, the only person that has done a grammar without a writing system was Panini in I don't know how, and I really don't know if it's true or not. So
Actually, it is written.
okay. So I don't think that we can make linguistic without writing. I think that it's really hard. Maybe when AI will make impossible stuffs, but for the moment, I think that writing is really, I don't know why in linguistics the role of writing is so
I mean,
under.
we also are used to writing.
Yeah,
It's so
yeah.
natural to us, and it's
Yeah.
yeah, but
But actually, that's why we are here, you know.
Yeah.
It's important.
Yeah, I know. Yes.
There was another question, Michael, very briefly, please.
Very brief, I can do just one, otherwise.
Thanks so much.
At your poster, you emphasize the point that you only transcribe signs in isolation.
No.
Okay, so you're reverting that.
No, okay, continue your, sorry.
Because this is, since you're talking about a corpus now, you're talking about transcribing continuous sign and not just isolated signs.
In our poster, we decide to choose an isolated corpus because an isolated sign because of the purpose of the no, sorry, I have checked Claire that make me signs. So in our corpus there is a sentence, and it was on the iPad, but maybe the iPad wasn't enough visible, and so we choose to analyze just one sign that was inside the sentence. And we decide what was the initial posture that we did, what we want to analyze, and then the movement analysis of just one sign, because for a posture it was too complicated to make all the sentence. But we can.
I heard you say you did not deal with sentence.
No, I don't deal with syntax. So the analysis of the meaning, etc., is not my job. I do the equivalent of articulatory phonetic. So the meaning is your job, not mine.
You did several times here talk about detecting initial posture. So what,
Yes.
you know, how continuous or how chunked?
It's for me, we give a tool to researcher, and then they have to s'appropriate of the tool. And yes, and so maybe when we have enough data, we will find a way to decide where the initial posture have to be, but not for the moment. We have not enough data. And maybe working with sign language linguists and gestural linguists, we will find more precise way to say, okay, the best point for the initial posture is this. For the moment, there is one. I put it there. I put it just a little bit after, and